Here, suppose the molecular formula is given to you COCl3 6H2O. That means this compound having three isomers. In first case, all the water molecules are present in coordination pair and all three Cls are outside the coordination pair. But in second case, it is possible only 5 water molecule inside, 1 Cl again inside, only 2 Cl outside and 1 water molecule is there. In third case, it is possible 4 H2O molecule inside, with that there are 2 Cl inside, only 1 Cl is outside with 2 water molecule. Means if you see all three compounds having same molecular formula, 6 water molecule, 3 Cl, 6 water molecule, 3 Cl, 6 water molecule, 3 Cl. But what is the difference? Here all the water molecules are inside. In second case 5 water molecules are inside, 1 outside. In third case 4 water molecules are inside, 1 water molecule outside. The relation is depends on how many water molecules present inside and outside, that will differ the compounds with each other. That's why the isomers called as hydrate isomers. That's why called as hydrate isomer. Some examples we are going to consider here. The another example is given here, COEN2 H2O Cl2 and COEN2 Cl2 H2O ClH2O. Look at here. In first, how many cobalt? 2 each cobalt. There are 2 ethylene diamine, 2 ethylene diamine. How many water molecule? 1 water molecule, 1 water molecule. 3 Cl, 3 Cl. Means both having the same molecular formula. What is the difference? In first case, the water molecule present inside the square coordination pair, but in second case, the water molecule present outside of the coordination pair. That means both are hydrate isomer of each other. So just see, if water molecules are present inside and outside, that time you easily say it is a hydrated isomer. First is ionization, second also like ionization, but here just depends on how many water molecules present inside and outside, that will decide, that will differ the two compounds with each other. That means there is a hydrate isomer. There are some examples given to you. In third case, there is a ligand isomerism. In third case, there is a ligand isomerism. Okay, so what is a ligand isomerism? It is a isomerism due to presence of isomerism in ligand itself. Means the ligand, a special ligand itself has a isomerism, and if two different isomers of ligand present in different compounds, that time we say there is a ligand isomerism. For that, the simple example here is consider 1,2-diamine. So CH2, CH, CH3, NH2, NH2. So what is the name of this? This is a 1,2-diamine propane, right? And it represented as short form PN. It represented as a PN. Just like a ethylene diamine is a EN, here is a 1,2-diamine propane is a PN. But you well know in organic chemistry there is a positional isomers. Two NH2 groups at the 1,2 position. In second case, it is possible both the NH3 at a 1,3 position. So the another isomer of same is this one. So both having same molecular formula and both are the ligands. Both are the ligands. So first ligand has 1,2 position, second ligand has 1,3 position, and their name is 1,3-diamine propane or trimethylene propane. So it represented as a TN. It represented as a TN. So suppose these two isomers, because both having the same molecular formula, but there it's themselves they are the in isomeric form. In first compound, suppose this form is present in a coordination complex. In second coordination complex, this form is present, and both the coordination complexes having same molecular formula. That time these two coordination complexes are isomer of each other, and this isomer called as ligand isomerism. So ligand isomerism found in only some cases, exceptional cases, because only few ligand has the tendency to make a isomer of them itself. So it is the PN and it is the TN. So for that we consider the example here. Okay, so these are two examples, both having cobalt, both having Cl, 2Cl2, and PN and TN both having same molecular formula. But what is the difference? PN means 1,2-diamine, TN means 1,3-diamine. So here the molecular formula is same, but the ligand which are present here itself has the isomerism. That's why these two are also isomer of each other. But why these isomers of each other? Was due to ligand isomerism. That's why called as ligand isomerism. That's why called as ligand isomerism. So it is a condition, depends what is the condition for to identify which isomerism is present. Just important is this is a PN and TN. Okay, so in first case, how cation and anion is very important. In second case, water molecule, see the water molecules. In third case, see the, it is the ligand, this type of ligand is present, PN, TN. Okay, so PN means 1,2-diamine propane and TN means 1,3-diamine propane, means it is the TN means it is a trimethylene diamine. Trimethylene diamine, that's why it represented as a TN, and here dimethylene, it is just 1,2-diamine propane, that's why it represented as a PN. Okay, so this is all about the ligand isomerism. Fourth type is going to discuss linkage. Some examples are more given to you in a notes. Linkage isomerism. So linkage isomerism means what? I already told you some monodentate ligand in itself has the two donor atoms. But in some complexes, they donate the electron through the one atom. In second case, they donate the electron to the another atom. But nature of ligand is monodentate, not a bidentate or tridentate. Bidentate ligand donate the electron through the both the atoms. Okay, but the monodentate ligand itself has tendency to donate the electron to the central atom through the two different atoms. In first case, one atom. In second case, another atom. Both the atoms not used in one time. They use both the atom in a different conditions, different complexes. So here the linkage form with the ligand is different in two coordination complexes. Some ligands, which are the ligands? Suppose we consider NO2 minus, then SCN minus, then S2O3 2 minus. These three ligands has tendency to donate the electron to the central metal through the two different atoms. NO2 has tendency to donate the electron by nitrogen and oxygen. Here by sulfur by nitrogen. Here by sulfur by oxygen. Means when it donate the electron from nitrogen, that time we represent it as a NO2. So in NO2, it represented as a nitrogen. It donated by the nitrogen. In case of SCN, it donated by the sulfur. In case of S2O3, it donated by the sulfur. But if we write this NO2 as a ONO minus, that time it represent or it donate the electron through the oxygen atom. If we write CNS that time, or there is a NCS, that means the nitrogen donate the electron. And if we write the thiosulfate group as a O, S2O2 minus 2 minus S2O2, that means oxygen donate the electrons. So these three ligands has tendency to donate the electron through different way. NO2 has tendency to donate the electron through nitrogen as well as oxygen, both having same. SCN or NCS both are same, but in first case donate the electron through the sulfur, in second case donate the electron through the nitrogen. But in third case thiosulfate donate the electron from sulfur as well as oxygen. So which atom attached to the metal? So if we consider this ligand present in one complex and this ligand present in second complex, if it is clear the nitrogen attached to the metal, but in that case oxygen attached to the, means linkage are different from the two different linkage, but overall molecular formula is same. That means the relation between them is linkage isomers. Linkage isomers and linkage isomer. So only these three ligands, monodentate ligands, are responsible to make the linkage type of isomerism. So we're going to discuss some examples here. The examples are okay. So let us see here. Both having same molecular formula, cobalt, 5NH3, 5NH3, Cl2, Cl2, NO2, again it is a NO2, but molecular formula is same. But what is the difference? In first in that given first example, nitrogen attached to the cobalt. So this type of linkage is formed, CON, but here COO linkage is formed. Okay, that means here CON linkage is formed, here COO linkage is formed. So both are different linkages. In both compounds having different linkages with this ligand, so both are linkage isomer with each other. Another example is okay, CrH2O5SCN 2 plus, CrH2O5NCS 2 plus. What is the difference? Both having same molecular formula. Cr, 5H2O, 5H2, SCN, SCN. Okay, don't think about the oxidation state. Means both having same molecular formula. That means both are same, but if you see in first case the Cr attached to the sulfur, this linkage is formed, but in that case Cr attached to NCS, so the linkages formed here are different, means both are linkage isomer of each other. So to understand which isomerism is present, just think about, is it any monodentate ligand is present which has the two donor atoms, and only three atoms are three monodentate ligand, NO2, SCN and thiosulfate S2O3 2 minus. So this type of isomerism is linkage isomerism. Okay. We are going to discuss the fifth one is coordination isomerism. Coordination isomerism. Okay, we move to the next, coordination isomerism. Coordination isomerism means what? The meaning is there, coordination means here is the differences in coordination pair. So basically here the two complexes are given, one complex is cation, another complex is anion, both are together, and in first case the ligand present in cationic complex is different and anionic complex is different, but in second case cationic complex replace the ligands with each other. So there is a replacement of ligand with each other. For that you consider simple example, CO NH36 Cr Cn6, the complex is given. Overall, if you see what is the charge, there are how many Cn? 6 Cn means how many charge? -6. Neutral is 0. So what is the charge? If you consider oxidation state and without calculation you easily predict the oxidation state, but how it possible? Here is a -6, here is a x, plus there is a 0 x. So 2x plus -6 is equal to 0. So 2x is equal to plus 6. That means x is equal to plus 3. X is equal to plus 3. Okay, it is oxidation state. But here, what is oxidation state of Cr? Plus 3. What is the charge of Cn? -6. So this complex having -3 charge. But here again cobalt has plus 3 oxidation state, here is a 0, the complex is having plus 3 charge. So here cation and anion is present. You consider this is a one coordination complex. One coordination complex, we write there isomer in next. So here one is cation, another is anion. Okay. So here in cationic part cobalt is present, in anionic complex chromium is central metal. But in second case what happened? CO Cn6 Cr NH36. So this is the isomer. How it? You know cobalt and chromium both having plus 3 oxidation state. If here is a plus 3 and -6 charge, so this complex having -3. Here is a plus 3, here is a 0, this complex having plus 3. So plus 3 -3 neutral. Plus 3 -3 neutral. But what is the difference? In first case, cobalt has cationic part, chromium is the anionic part. But here cobalt is anionic part and chromium has cationic part. Means, see here, cobalt is part of the cation, here cobalt part of the anion. Chromium is a part of anion, here chromium part of the cation. Why this happen? So just exchanges or replacement of the ligand with each other in a coordination pair. So in a coordination pair there is a different ligands are present, but overall the complex is having the same molecular formula. 6 NH3, 6 NH3, 6 cyanide, 6 cyanide, 1 chromium, 1 chromium, 1 cobalt, 1 cobalt. Means both pairs having the same molecular formula, but in a coordination pair, both having different ligands. That means coordination pair itself undergoes the isomerization. So just coordination pair differ. What is the difference here? Both are differ by the presence of ligand in a coordination pair. That's why called as coordination isomers. Okay, so it is the fifth type of isomerism. Next one is coordination position isomers. Coordination position isomers. Coordination positions isomers. Again it is the same related to the coordination pair, means just position of ligand is changed in coordination pair. Okay, and basically this type of isomerism is present or possible in the bridging complexes. So coordination position possible in bridging complexes. You will understand when we consider the example here. CO NH34 OH OH CO and here is a NH3 twice Cl2 and SO4, and Look at here. Both having same molecular formula. First see, is it molecular formula is same? 2 cobalt, yes, 2 cobalt, 2 bridging OH, 2 bridging OH, 3 and 2, 6 NH3, 3 plus 3, 6 NH3, 2 Cl, there are 2 Cl, 1 sulfate, 1 sulfate, means both having same molecular formula. But if you see the positions of the ligand in a coordination pair, look at here. First cobalt has 4 NH3, second cobalt has 2 NH3 and 2 Cl. But in second case, this cobalt has 3 NH3, 1 Cl, 3 NH3, 1 Cl. Means coordination position of the ligand is just changed in first as a in second case. But overall both having the same molecular formula. So in a bridging complexes, if one of the ligand change their position in second case, so Cl2, both Cl2 attach here, but in second case one of the Cl comes on the position and that position, and here 4 NH3, 1 NH3 goes at another position. So 1 NH3 goes here. So 2 Cl, out of 2 Cl, 1 Cl come here and 1 NH3 goes here. So just the alter the position of ligand with each other in a bridging complexes. So the relation between them is coordination position isomerism. It is very easier. And last one is polymerization. What is the polymerization? The monomer converts into polymers, means it is the repetition of empirical formula. That means, you know, polythene, polyester, polyethylene, means ethylene is the monomer. It is the empirical formula CH2 double bond CH2, and it is a repeated. It is converts into polymer. So just increase the molecular weight by repeating the empirical formula is the polymerization. Same thing is here. If two compound having different conditions but they has the same empirical formula, that are the polymerization isomer of each other. So for that we consider here example CONH3 thrice, NO2 thrice, and CO NH3 6, CO NO2 6. Okay, look at here. What is the empirical formula? Here CO, one CO containing 3 NH3 and 3 NO2. Okay, there is a twice is given. That means here 2 cobalt, 6 NH3, 6 NO2 are present. Means cobalt having, what is the empirical formula? Empirical formula is this one. So this is the empirical formula. Here 2 units are present. That means it is multiplied 2, 3, 4, 5, 6. But in second case, here each cobalt having 3 NH3 and 3 NO2. But here one cobalt having 6 NH3, another cobalt having 6 NO2. But overall if consider their empirical formula, both are cobalt. So each cobalt containing, both are cobalt, so 3 NH3 and 3 NO2. Each cobalt containing, here 2 cobalts, so one cobalt containing 3 NH3, 3 NO2, second cobalt also containing 3, so this is just representation is different. Here this is the empirical formula, here is a multiplication. Okay, if here 3's are given, so again it is divided in different way, 3 NO2. If here 3 given, so how we write the another polymerization here? This way, CO. So if there is a 3 CO, we expect 9 NH3, 9 NO2, right? So here, It is the first case. In second case, CO if you see this 3, what is the meaning of that? How many cobalt? 3 cobalt. How many NH3? 4, 5, 6, 7, 8, 9 NH3. How many NO2? 2. Then 3, 5, and 4, 9. Means 3 cobalt, 9 NH3, 9 NO2. That means each cobalt containing 3 NH3, 3 NO2. That means again giving the same empirical formula. Again this one also the polymerization isomer of this one. So this way there is a repetition. There is a repetition of the, just change the number of ligands, but overall the whole complex getting same empirical formula. This complex getting same empirical formula, this also getting same empirical formula, this having also same empirical formula. That means all are the coordination isomer of each other. So this is all about the structural isomerism of coordination complexes. In next lecture we discuss the stereoisomerism in a coordination complexes. So today we stop here. If you have any difficulty, you put messages in a group, okay, or you can send personally.